In this lesson, we're going to understand and identify categories of numbers: natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Okay, so let's talk about these real numbers. The first numbers you learn as early as a toddler are your counting numbers: 1, 2, 3, and so forth. These numbers are also called natural numbers, and again, they start from 1 and go on and on and on to infinity. Now, the next set of numbers are the whole numbers, and the whole number just have one digit more than what the natural numbers have, and that number is 0. When you add 0 to the natural numbers, it is then called your whole numbers, and the whole number starts from 0, then 1, 2, 3, and so forth. These are your whole numbers. The next set of numbers are when you include the negatives with those. So in other words, it's your whole numbers, the set of whole numbers, but including the negatives now. So when we include the negatives in, it is then called integers. And integers are your negatives, your positives, with 0 in between. Okay, so you have your negatives on the left, you have your positives on the right, and you have 0 in between. The next set of numbers are numbers that we refer to as rational numbers or fractions. Now, these are just any whole number that you can write as a fraction, then we call it a rational number. So, for example, 12 is a whole number. We can write it as a fraction by just writing it as 12 over 1. So any number that can be written as a fraction where the denominator is not 0, it's called a rational number. Another example is 1/3. 1/3 is also a rational number. Now, we'll also get into the fact that certain fractions, we can write them as a repeating or a terminating decimals. Now, with these rational numbers, they can be either terminating, or you can have a number that repeats itself. But moving on, again, let's focus on rational numbers, any number that can be written as a fraction. 5/10 is also a rational number. -2/7, it doesn't matter whether a rational number is negative or positive. It can be both a negative or positive. As long as you can write it as a fraction, it's a rational number. Now, let's talk about the opposite of rational numbers. The opposite of that would be irrational numbers. And think of irrational numbers are numbers that cannot be written as a fraction, or numbers that just are, think of it as irrational. They just go on and on, crazy. Something that is irrational is crazy. Well, irrational numbers are numbers that just can go on forever, such as pi. We know that pi approximates into 3.14, but actually pi goes on and on and on. We just approximate it to 3.14. So irrational numbers are numbers that are non-terminating and non-repeating. They don't stop, and they just go on and on and on, and none of the numbers repeat themselves. They're just random numbers. They're irrational. Think of it as crazy. Anything that you can think of to help you remember irrational numbers. Again, they are numbers or decimals that are non-terminating, and non-repeating. So anything associated with pi would also be irrational. Other things are non-perfect square roots, for example, or it don't have to be square root, any root. Non-perfect roots would also be irrational numbers. For example, the square root of 4 is a perfect square root. It equals 2. But the square root of 2 is not a perfect square root. So, and we see here what it equals, and actually on your calculator, when you do the square root of 2, it's going to give you several digits for as long as your calculator window allows for. But it actually goes on even more, but you're only going to see just the amount of space that your calculator window has. So again, these irrational numbers, they go on and on. And again, anything that's associated with pi, whether you add with pi, divide by pi, multiply by pi, it's going to produce irrational numbers. And it doesn't matter whether your root is negative, it has a negative in front of it, or has a positive in front of it, it's still going to produce an irrational number. Okay? So you have rational numbers, and then you have irrational numbers. We talked about so far all of these numbers: natural numbers, whole numbers, integers, rational numbers, irrational numbers. All of those numbers fall under the umbrella or under the category of a real number. Now, let's classify a few numbers just to do some practice to make sure we got the concept of these numbers. So 5. Would you say that 5 is in the set of natural numbers? Yes, it is, because remember, starts with 1 and goes on and on. So yes, it's going to include 5. How about whole numbers? Yes, remember, it's going to include that as well, because whole number, the only difference between that and the natural number is the number 0. So yes, 5 is in the set of whole numbers. Is 5 in the set of integers? Yes, it is, because integers are your negatives and your positives. 5 is a positive, so it's going to be included in the integers. Next, rational number. Can 5 be written as a fraction? Yes, it can. 5 over 1 is a fraction, so yes, it's a rational number. Now, the thing you have to remember is a number can't be rational and irrational at the same time. You're one or the other. You're either rational or you're irrational. And so since it is a rational number that can be written as a fraction, it's not irrational. However, all numbers fall under the category of being a real number, so we would definitely check that. Moving on, negative 3/4. Is that in the set of natural numbers? No, it is not. Natural numbers include your whole numbers. No fractions are involved in there. Nor is it a whole number. So not a natural number, not a whole number. It's not the integer, which we call our whole numbers, negatives and positives. It is a rational number, though, a number that can be written as a fraction. It is already a fraction. It's negative 3/4. And again, as I said before, if you're rational, you can't be irrational. So the next category then is, yes, all numbers fall under the real category. Next, 1.5. 1.5, is that a natural number? No. Is it a whole number? No. Because again, this is a decimal. Natural numbers and whole numbers are whole digits. It doesn't have in between digits. Is it an integer? No. Again, it's all of these numbers are numbers that are whole digits, whole numbers. Is it a rational number? Yes, it is, because this can be read as 1 and 5/10, because this is the 10th place. So 1 and 5/10. If you're rational, You can't be irrational, so we don't check that. And yes, it is a real number. The square root of 7, is that a natural number? No. Is it a whole number? No. Is it an integer? No. Can we write that as a fraction? Well, no. It's not like a whole number. It is irrational because it's not perfect. And yes, it is a real number. Now you think of, okay, well, we can write this as a fraction as the square root of 7 over 1. When we talk about writing it as a rational number, we don't mean one that includes a irrational. If it's irrational, remember it can't be rational. And because the square root of 7, when you type that in your calculator, it's going to give you digits that run off the calculator. None of the digits repeat themselves, and it goes on and on and on. So therefore, it's classified as an irrational. And again, you can't be classified as a rational and irrational. As soon as you realize that it's irrational because it's a non-perfect root, then you automatically know that it can't be rational. 0, is 0 in the natural numbers? No. Okay, because remember, natural numbers start with 1. 0 in the whole numbers? Absolutely, because that's one of the first numbers in the whole number set. Is it an integer? Yes, it's right in between those negatives and positive. Is it a rational number? Yes, it is a rational number. And remember, if you're rational, you can't be irrational. So let's move on to real number, which, yes, it is a real number. Next, we have a 2 that goes on and on, repeating itself, 0.2222, not in the natural numbers, whole numbers, or integers. For a rational number, now, it doesn't mean because this goes on and on that it's irrational. Remember, for rational, you are rational if your numbers stop or if they are repeating, if a number repeats themselves. And since the 2 repeat itself, it falls under the category of rational. Okay? Whenever you have digits that don't repeat themselves, they're just all types of crazy numbers, that's going to be irrational. But again, this one is rational. Is it a real number? Of course. Last one, 3 times pi. Anybody associated with pi, remember, it's going to be what? Yes, irrational. But first, is it in the whole numbers? I mean, natural numbers? No. Whole numbers? No. Integers? No. Now, it's either rational or irrational. Remember, pi and everybody associated with pi is going to be irrational. It's going to produce a number that goes on and on and on. And none of the numbers are going to repeat themselves. And then all numbers fall under the real category. And there you have it, classifying numbers.